Hello everyone, my name is Shikha Jain, and in this DA lecture series we move on to unit 2. In this particular unit we will first talk about red black tree. What is red black tree? A red black tree is self-balancing binary search tree. It is a self-balancing BST, where each node follows some rules, and those rules are that every node should be either red or black. Any of the node in red black tree is either red or black. Root node is always black. There is no two adjacent red nodes. A red node cannot have a red parent or red child. That means if a parent node is red, then child node should not be red. If the parent node is black, then child node can be red. It is true. If the parent node is red and the child node is black, that is also true. So no two adjacent nodes are red. That is the case of binary red black tree, and it is a self-balancing binary search tree. And every path from a node, including root node, to any of its descendants, null node, have the same number of black nodes. So every path from the root node, that means from the root node till the leaf node, the number of black nodes should be same. From the root node till the leaf node, the number of black nodes should be same in every path. At every path, suppose we have this path, or we have this path, or we have this path. In every path, let's suppose in this path also. But because red black tree is a binary tree, it's a binary search tree, so no three nodes would take this. But for an example, for this particular path, the number of black nodes would be same for this path, and for this path also. The number of black nodes should be same. But because this is binary search tree, it does not follow three nodes, three child case. It only follows two child case. So why we learn about red black tree? Because most of the BST operation takes O of H time. Most of the BST operation takes O of H time, where H is the height of the BST. Because in some case, when the nodes are like 10, 20, 30. So what our BST would be like? 10, 20, 30. So this is what? 20 is greater than 10, so it would be right child. 30 is greater than 20, so it would be right child. So this is right squared binary search tree. And if we have node like 30, 20, 10, so the BST would be like this. So it is left squared binary search tree. So when the case of left squared binary search tree and right squared binary search tree, the time taken for any BST operation is O of H. So we want to reduce this time for the operations. So that's why height balancing came into consideration, and one of the height balance trees, AVL tree, Adelsky, Walensky, Landis, AVL tree. This is also height balance tree. It has some factor associated with it, and we can do left rotation, left right rotation, right rotation, and right left rotation. These are 4 rotation happens in AVL tree. So AVL is also a height balance tree. But why we study red black tree when AVL is there and AVL is also height balanced? Why we study this red black tree? Because in AVL is more balanced as compared to BST. So it is more advantageous. AVL is more advantageous than red black tree, but there may some cases occur when the number of rotations in AVL would increases. Number of rotation increases during the insertion and deletion operation. So if our application involves any frequent insertion and deletion, if one of the application involves frequent insertion and deletion, so red black tree is preferred. So if the insertion and deletion are less frequent and search is more frequent operation, then AVL tree should be preferred over red black tree. If the search is considered, then AVL tree is considered, preferred, and when the insertion and deletion is considered, then red black tree is preferred. So how does this red black tree maintain its properties? Black height of red black tree. There is a term called as black height. What is this black height? So this is very important topic from the examination point of view, because every year one of the question would be from red black tree only. So there is a term called as black height of arbitrary red black tree. What is this term? Black height is the number of black nodes, on a path from root to leaf. So black height is this number of black nodes on the path from root to leaf. Leaf nodes are also counted as black nodes. So we can say that leaf nodes are also black nodes. That is also counted in this. So these are some of the properties of red black tree, that the root node is always black, and the no red parent, no red child would be there. So this is one of the properties of red black tree. Next comes insertion in red black tree. So for insertion in red black tree, there are some rules. What are those rules? First, we need to perform BST insertion. The insertion would be taken place like BST insertion, and the freshly inserted node is always of red color. Next rule is, if X is root, then X must be black. That means if root node is freshly inserted node, then it is first time it is red, then because this is the root node, we will change to red color. Now the third rule, if freshly inserted node X is of red color and parent is also of red color, if the parent is of red color and the child is also of red color, then we see the uncle's color. Then we will see the color of uncles. We need to check uncle's color. Let's see what are the rules for insertion into a. When the uncle's color is red, the A part of this is, when the uncle's color is red, then we need to change the color of parent X, change the color of parent, change the color of grandparent, and change the color of uncle as well. If the uncle is red, then we need to change the color of parent, grandparent, and uncle. So we need to change color of all the three members of the family, upper level family members, right? Next is, if uncle color is black. If the uncle color is black, so we need to check that first, this is triangle child or inline child. So there are two rules, whether it is triangle child or inline child. What is the meaning of triangle child? That if a inserted node, this is root node obviously, so this is of black color, this is of red color, and this is of red color. Insertion takes place here, and the uncle is here, and uncle color is black, and insertion takes place here. So when the insertion takes place here, so the uncle color is black and it is triangle child. Or other case of triangle child is uncle is black, parent is red, child is red, and grandparent is black. So uncle color is black, red ka red child hai, and this is triangle child. This is two cases of triangle child. What is the meaning of inline child? If the insertion takes place like this, here parent color is red, insertion takes place in this way, and it's an inline child and uncle color is black, or we can say inline child means this is uncle color is black and this is inline child. So what are the rule? What we would do in triangle child and inline child? Let's see. When this is inline child, say for inline child, we need to right rotate grandparent, we need to right rotate the grandparent, and we will swap the color of parent and grandparent. We will swap the color of parent and grandparent. We need to swap the color of parent and grandparent when it is inline child. And when it is triangle child, for triangle child case, first we will left rotate or right rotate parent. We will left rotate or right rotate parent. In that case, we will left rotate or right rotate parent and follow case of inline child. Then we will follow the case of inline child, because if some member, if there is a triangle child, this is red, this is red, this is black, and this is black, and here is an insertion and here is the violation of the rule, then it will see that uncle is black and this is a triangle child. So it will move the parent in the opposite direction. So this is black, this is red, and this will red, because it will move in the opposite direction. The parent will move in the opposite direction. When the parent is moving in the opposite direction, then it will form the cases of inline child. And when the inline child case occurs, then grandparent rotate in the opposite direction. Then grandparent will rotate in the opposite direction, and it will become the root node. It will go down, and this would be of red color. And we will follow the cases of inline child. Because in inline child, we will rotate in opposite we will rotate grandparent in opposite direction and swap the color of parent and grandparent. Let's take an example to solve the question of red black. Let's suppose we need to insert 10, 20, 30 and 15 in an empty red black tree. So first 10 is inserted. Because this is the root node, it is always of black color. Next come 20 is greater than 10. It will be red color. This is black. No property violation is there. Next is 30, 10, 20, 30. This is of red color. This is of red color. This is of black color. Now there is a violation in the rule, that is red, and this is red. This is violation in the rule. So there are nil node and it is of black color. The nil node are of black color only. So the uncle color is black and it is inline child. So what we will do, we will rotate grandparent in opposite direction. So 20 will become the root node. So we will move grandparent in the opposite direction and change the color of, swap the color of grandparent and parent. So it will become black and it will become red. Grandparent is 10 and parent is 20. So we will swap the color of grandparent and parent. So it will not violate any of the property of red black tree. Next comes 15. 15 is smaller than 10. 15 is greater than this. So this is of red color, this is of red color, this is 30 is of red color. Now there is property violation in this case also. Red has a red child. So uncle color is red. So what we will do, when the uncle color is red, we will swap the color of grandparent from black to red, from uncle from red to black, and from parent from red to black. So we have swapped the color of parent, grandparent and uncle. But now because the grandparent color is red, we will switch on over because grandparent can never be red. This slash is the changed color. So the grandparent color is red, so we cannot take red color of grandparent. So it will simply change to black color. So the final tree would be, this is of black color only, 10 is of black color, 30 is of black color and 15 is for red color, right? So this is how we will insert any of the nodes in the empty red black tree. Let's take another example of insertion in a red black tree. Let's suppose we have this particular scenario, 26, 8, this is the question. This is 11, and this is 3, this is of red color, red color, red color, and this is also of red color. And rest all other nodes are of nil nodes. All other nodes are nil nodes, and whatever I have not mentioned, that is of black color only, right? So we need to insert 2, 6, 13 into this red black tree. So which type of questions came in this particular topic? That insert these nodes in an empty red black tree. So first we need to insert 2 into this tree. So when we insert 2 into this tree, so 2 is smaller than 7, 3 is small, 2 is smaller than this. So insertion of 2 will take place like this. So there is no property violation because this is of red color, black root node and red child. No property violation. Next is 6. 6 is lesser than 7. 6 is greater than 7. So 6 would be like here. This is of red color. No property violation is there. Next is 13. 13 is greater than 7. 13 is smaller than 18. 13 is greater than 10. 13 is greater than this. So here we will insert 13. Now when we are inserting 13 in this is of red color. So red child, this is a property violation. So what we need to do, we will check the uncle's color. Uncle's color is red. So when the uncle's color is red, we need to swap the color of uncle from red to black, parent from red to black, grandparent from black to red. So these 3 colors we have changed and assigned a new color to these nodes. So we can simply insert any of the node in an empty red black tree. So this is one of the example of insertion into an empty red black tree.